Hello everyone. In our last video, we have explained to you how to calculate the ultimate load carrying capacity of double and multiple under-reamed pile. Today, in this video, we will take one example for double under-reamed pile. So let's take an example. On double under-reamed pile. We want to determine the ultimate load carrying capacity of the double under-reamed pile. So let's say this is the pile. This is the double under-reamed pile embedded into cohesive ground. The value of Cu, let's say the undrained cohesion is 80 kilopascal and the value of alpha adhesion factor is 0.6. The diameter of the pile is 0.5 meter. So D equal to 0.5 meter. Therefore, you can find out, these are the given data. Therefore, we can find out the diameter of the bulb or diameter of the under-ream. How much it will be? The diameter of the under-ream du can be calculated. It's going to be 2.5 times the shaft dia. So therefore, this is going to be 1.25 meter. Right? So this is going to be 1.25 meter. And center to center distance. This is the center to center distance between the two bulbs. Distance between two bulbs will be calculated 1.25 times du. So 1.25 into 1.25, this is going to be 1.56 meter. Fine. Now, this distance, if you want to find out, this angle is 45 degree, this angle is 45 degree in under-ream. Therefore, if we want to find out this distance, how much it will be? This distance will be 1.25 meter minus this shaft diameter, that is 0.5 meter, and that will give you sum of these two dimensions. Beyond this side, divided by 2, if you do it, you will get this. So this is going to be 0.75 divided by 2. So it is 0.375 meter. So this dimension is 0.375 meter. So this side also, this dimension will be 0.375 meter. And because this is 45 degree, this is 90 degree. This is also 45 degree. So this side and this side will be equal. So this is also going to be 0.375. Hence, this is also 0.375. So total is going to be 0.75. Right? And center to center distance is known to us. Therefore, we can also find out the distance between the two bulbs. This distance can be also found out. How? This we know it is 1.56. So 1.56 meter minus. This is going to be 0.375 and this is also going to be 0.375. So if you deduct this, naturally you get this. So 0.75, if you deduct it, 0.75. So this becomes 0.81 meter. So simple. All dimensions must be calculated. So here also, this is 0.375 meter, 0.375, and this is the bucket length. Bucket length is given in this problem. The bucket length is 0. So this then distance is taken as 0.5. And also it is given that the first bulb is located from the ground level at a depth of 3 meter. So first bulb at 3 meter from GL, ground level, right? Therefore, now we can calculate the ultimate load carrying capacity. The formula well known to all of you. I have already explained. It is going to be due to a skin friction. The load carried due to a skin friction, that is the first component, plus the load carried at the end, at the pile stick, QE, plus the load carried by the bulb is QB, that is the third component, and as you know that the soil within these two bulbs is going to be confined and it's going to act as if it is one unit. Therefore, the friction which is going to come into picture is going to be between soil and soils. Soil here, soil within these two bulbs, and that is called the load transfer between due to friction developed between soil and soil, QSS. So there are 4 components. Each component can be computed. The skin friction, Fs, that is going to get developed on the shaft. So unit skin friction is alpha times Cu, multiplied by, this is 3 meter, this is 0.5 meter. So 20 meter is going to be pi d into 3.5 meter. So this is the value of QS, load transfer through a skin friction. So this can be computed, 0.6 into Cu, undrained cohesion is 80 kilopascal, pi, this is going to be shaft dia 0.5 into 3.5, 0.5 and 3 meter. So this can be calculated and we can get the value of QS. So let me calculate now. This comes out to be 263.89. So value of QS is, when we calculate it, is 263.89 kilonewton. 263.89 kilometer. So we have been able to calculate the first component. What is the second component? It is QE. So let us calculate. That is at the end. So at the end, this is the unit embedding. So the load transfer at the end is going to be QE multiplied by area at the end. That means it is 9 times, QE will be 9 times Cu, and area at the end will be pi by 4 into d square. So let's calculate. In kilonewton you will get the value. 9 8 is 72, so 720. So let us calculate 720. Square. This comes out to be 141.37. So this is 141.37 kilonewton. Now, the third term is QB. So let's calculate that. So load transfer through the bulb. So this is the bottommost bulb that will carry the resistance when you apply the ultimate load, axial load. So load transfer, load resisted by the bulb is 9 times Cu. Remember the theory, I have already explained all these things in the theory part, multiplied by area, that is pi by 4, and this will be du square, diameter of the under ream, minus ds square. So this is 725 by 4 into 1.5 0.25 square minus 0.5 square kilometer. So if we calculate it, let us calculate. This is coming out to be 742.2 kilonewton. So this is going to be 742.2. So this third part is over. Now the last is Q, load transfer between soil and soil. So here you can just see that the soil which is between these two under-ream is going to act as if it is a part of this under-ream itself. So the skin friction FSS is going to be Cu between soil and soil. So Cu means 80. Now what is the surface area over which this FSS is acting? The surface area is cylindrical, so the perimeter is going to be pi times du. Pi times du into center to center distance is already known to us, 1.56. Let us calculate this. This is 490.08. 490.08. So you can see the contribution of the bulb is going to be 742 kilonewton. Great contribution. Here at the periphery it is 490. So it's a huge contribution. So the ultimate load carrying capacity of double under-ream pile is much more, almost more than 2.5 times more than the normal piles. Because of this under-ream, you can see the contribution of the bulb, how the things are going to increase. So total QUU, how much it is there? So therefore the ultimate load carrying capacity is 490 plus 742 plus 141.37 263.89 263.89 plus 141. 37 plus 742.2 plus 490.08. So the ultimate load carrying capacity comes out to be 1637.54 kilonewton. And therefore, if you want to find out the safe load this pile can carry, you should divide this by 2.5. So if you divide it by a factor of safety equal to 2.5, this is the safe load that this pile can carry. But suppose, what is the total length of this pile? You say 3 meter. Let us calculate. 3 plus 0.75, okay, and 0.75, so 1.5, so 4.5 plus 0.5, 5.81. The total length including all, it's coming to be 5.81 meter. So if it is a normal pipe of 5.81, there is no bulb. So it is like this, simple, no bulb. So this is a simple pipe having no bulb. Then there will be only a skin friction and the total length becomes 5.81 meter. So from ground level up to here. So very easy to calculate. There will be only 2 terms, no contribution of bulb. So this will be alpha times Cu into pi d into L plus 9 times Cu into pi by 4 into d square. So if it is a simple pi, the load carrying capacity you can just calculate. This is 438.06 kilonewton, and what about this? The second term becomes will become 141.37. So this will become 141.37. So how much the total you are going to get? This is 438.06 plus 141.37. So the ultimate load carrying capacity of normal pipe is going to be 579.4 kilonewton. So that was 1600. This is only 547, 3 times more. So that's the great contribution which the double under-ream pile provides. Say if it is multi under-reamed pile, So you will have number of bulbs. Let's say more than 2 bulbs, it is going to be multiple under-reamed pile. So for multiple under-reamed pile, let's say one bulb is here, the second bulb is here, the third bulb is here, this is called multiple under-reamed pile. So here you can find out between first bulb and the last bulb, you can find out the center to center distance. So this distance you should find out. And the calculation remains same. The last bulb will take the resistance under the vertical loading, and here end bearing, and over the shaft there will be a spring friction. So you can increase manifold 200%, more than 200%. You can increase the load carrying capacity by providing under-reamed pile. That's the beauty of this. Thank you very much.